one technical question that was asked that we didn't have a chance to answer. And Greg, I think I was going to ask you if you could do that one on, can you pull that up for yourself? I sent it to you. The test data shows very high hysteretic energy loss. Shouldn't you use overdamping? In this case, PGV would be a better intensity parameter. I wonder if we could just capture that one technical before we go on.
Yeah, I guess there's kind of two parts to that, the question about damping and energy dissipation. And that I think the strategy we use, which is kind of state of the art in research and practice, is to, first represent the structural models and the yielding and cracking and so forth. And naturally, energy is dissipated through that hysteretic action that you saw in those loops. So that's built into our models. And then there is some additional energy dissipation, which is not captured in those. These could be other components of the house we're not modeling. There could be some soil structure interaction. And so we do add some equivalent viscous damping into our models. We put in 2% equivalent viscous damping. There's always a question how much viscous damping to put in. So we did a sensitivity study to show the results are not sensitive to numbers, going down to 0% up to about 5 or 6%. So we feel that's representative. In terms of the intensity measure question, we used spectral acceleration basically because that's the state of practice. Everything the USGS puts out in terms of probabilistic seismic hazard design maps, that's all based on spectral acceleration. And also, to the extent it's pseudo-spectral acceleration, I don't think we'd be gaining much by going to pseudo-velocity. But certainly there are questions about what would be better intensity measures, but we really, for the scope of this project, stuck to industry practice, especially because we're handing over these damage models to the loss modeling companies who, again, have access to the hazard assessment in terms of spectral acceleration.
Great. Yusuf, did you want to add anything to that?
I agree with Greg. So the only thing I can add is that the models were calibrated or were validated against experimental work at San Diego and Berkeley. So whatever hysteretic loop that they come out of the testing, they capture that. And then beyond that, whatever Greg said is absolutely correct. Thank you.
Great, thank you very much. Well, first of all, a huge thank you to all of you for an incredible 2 days of presentations. As I think I mentioned earlier, we do have one more presentation by peer director Khalid Mosalam, and he can be here, he said maybe 2:15-ish. And so if we're just excitedly into discussion, we're gonna go all the way to our 2:30, but if I run out of things to say, other than a puppet show, we're gonna move into our last presentation. But I think with this brain trust in front of me, we're gonna have no trouble. But let me set the stage here, because as Chief Mitigation Officer for the California Earthquake Authority, I'm in just a really exciting position to directly implement the information and products from the research projects that have just been described in this forum. And that doesn't mean that I have the budget right now, that I have the potential funding. What I have is the charge. And the charge is to increase mitigation for all 40 million Californians. And obviously, my ideas are this big, and reality will be this big, but let's dream for a bit, and particularly with the tools that were just described to us. So I wanted to just throw out a couple of things to set the stage. And one of them is what's been really exciting across all of the projects is, that we've asked ourselves to talk about damage and not life safety. And for peer whose title includes performance-based engineering, and for those of you who are not technical, performance-based engineering, it was a huge step. That I think I can say that maybe kind of in the late 1980s, there was something in the Structural Engineering Association called Vision 2000, which was to say, let's step away from saying your house was constructed, your home, your building, your office building was constructed to code, which is essentially a life safety performance level expectation. And let's talk about what the occupancy of the building needs, what the building owner may need. And in the case of residential, obviously we're talking about habitability. And I will tell you, as a structural engineer at the time, it was huge. And there were a lot of engineers who didn't want anything to do with it. They thought, how in the world can we predict? They thought it was, there's a little voodoo going on there. And I think they forgot how much voodoo frankly is in the building code as well. But it was visionary, and performance-based engineering is the way that we describe this, with the idea that let's just take a regular office building for a very expected event, the small earthquake that doesn't generate a lot of damage, 5, we expect no structural damage. It absolutely is repairable to this office building. You get an earthquake that's a little bit bigger, and you might be willing to accept some damage that will mean that you have to be out of that office building for a short period of time. And then, of course, in the very rare, very large earthquake, you're willing to accept that will afford its occupants life safety, that they'll be able to egress, but that you, in fact, might need to be out for a few months. And then, of course, nuclear power plants, we're not going to accept really any damage. And something that's not occupied way down at the other end of the spectrum. And then every other building can fall somewhere on that spectrum. And when we started talking about ATC 110 and the PURE project, we were talking about damageability as it related to residential, which is habitability. And if you think about, say, pre-COVID, the tremendous impact on residential occupancy in California, we were absolutely just scrounging to build new housing, particularly in the areas of low income. And now impose on that an earthquake that just across the board puts hundreds of thousands of, maybe 10 to hundreds of thousands of people out on the street. Unacceptable. So that's an exciting thing to talk about. Cheryl Rabinovich, I mentioned to you when I showed the stair steps that she just this incredible conversation on our way up to Sacramento once, talking about simple visual cues that a homeowner can use to understand seismic vulnerabilities. Well, I will tell you, a cripple wall is pretty darn easy because we can use age as a proxy. I always say that the pre-1980 building house may have that vulnerability. The pre-1940 house does have that vulnerability. And then the tremendous information of, just the 4 sites being able to encompass the seismic hazard in California. Well, now I need to take that and I need to be able to tell somebody in Redding, in Sacramento, in San Diego, where they are. I reminisce about Zone 3 and Zone 4 was so simple. We're going to need to translate that into something that is that easy visual cue. So Earthquake Brace and Bolt started in 2013. I managed the program. We've now done over 12,000 houses in California. We provide $3,000 to a homeowner to do what we told you earlier was about a median $5,000 retrofit. It has to be code compliant, meaning done in accordance with the code, permitted, the whole thing. Currently funded through our loss mitigation fund and then FEMA funds. I think I just mentioned in talking to Frank, FEMA requires not only that you tell them approximately how many houses you're going to do in the program, but how big is the problem? And then what's the benefit cost ratio? And it is frustrating to me that I could barely get a cripple wall house to be greater than 1 in terms of benefit cost. And you guys just told me hundreds of thousands of dollars worth of savings. Doesn't matter because it's annualized. It's, anyway, I won't go into that. That's a whole other seminar. But the idea here is that here is information that I can use to go to FEMA and say, I've got better than your BCA calculator. I've got the PURE project. So there's implementation. I will tell you that one of the questions that Badi came up for all of you was about uncertainty. So let me put uncertainty into the chief mitigation officer's lexicon. Uncertainty to me is that it is so expensive for me to send an assessor out to a property to get a very careful assessment of what the vulnerabilities are, that it is less expensive for me to retrofit that house, assuming that it has had poor maintenance, that it has had some degradation, or that it's been damaged in a previous earthquake. That is uncertainty to me. I can't remove a lot of the uncertainty. The insurance side of the house is a whole other ballpark of the implications of uncertainty on premiums, of course, is huge. So let me stop there after having thrown some things out and see if I can start with the ATC 143 team. we are about to implement those projects. Training is huge, and what needs to be done in that arena? So Justin, let me start with you. With what I just described, where would you go next in terms of research or information around the 143 project?
Putting me on the spot, Janiele.
I am putting you first because you were first yesterday.
Oh, okay. Well, I think, we've got a great set of documents. And I think we've heard about I think Brett Lazendia gave a shout out to the documents in his presentation today, and he noted how the general guidelines, the one that's intended for insurance adjusters and building contractors, that the predecessor to the update of this document has been out for about 10 years now, and it's fairly widely known. But the engineering side of the house, because the predecessor to it was not complete, it just included the geotechnical aspects. Now we've completed it. It really is not that widely known. And so I think there's a big effort that should go into trying to disseminate the document, training engineers on some of the core principles of assessing buildings and then determining efficient repairs, because that sort of process is quite unique and is different compared with what many people are doing day in and day out. And retrofitting or certainly designing new buildings is just a completely different context than a post-earthquake context. So I think there's just a lot of there's a big need there, and there's a lot of value in trying to find the right channels to get the information out to engineers so that they understand that there's this great new tool available to them.
Great.
How about you, Morgan? What do you think?
I think you said it well, Justin. I think that a lot of work went into preparing the documents and sort of organizing the methodology behind them. And so I think now the next step for at least that project is disseminating it and making engineers aware of it and aware of the tools that are there.
So Kelly, I'm going to put you on the spot now because I don't think everybody knows. Kelly, I think you worked on every single one of the projects, just maybe not the Sim Center. Briefly, 116 informed 110, 110 informed Pier, all of those informed 143. Would that be a correct assessment?
I believe that's correct, yes.
And so what's the next unnumbered project? What would you choose?
Wow, that's a huge one. A lot of different directions that could go. I was listening to Justin talking about the education and thinking about Brett went out and worked with the claims adjuster, and they're all in the Xactimate world. So you have the whole world of what you could do with apps to help implement things, turn a paper book into a something else. In the testing front, we talked about lots of different directions we could go to augment the data, because at each step we had a very defined budget and time frame we had to fit into, and we were always choosing highest priority things. And so for me, it was in the testing, but all other aspects that everyone is involved in, they had to focus down the effort into what they were able to put forward. I know one of the things that was talked about in the Pier and that we developed a description of was the idea of a full building validation test, and the huge benefits that that would have in terms of proof of concept and communication of concept, but also in terms of going back and re-looking at every single one of the projects and what they put out. This is every single project that we've been talking about over these 2 days could go and use a test like that to look at how the loss modeling, how the damage assessment, how the numerical modeling relates to that one particular example. So certainly a whole world of validation. Tons of different directions that we could go in, but that's kind of what comes to mind for me.
Yeah. So Brett, and you guys raise your hand if anybody thinks of something. But Brett, I wanted to ask you, since we're just talking about 143, and Kelly was just right smack in that area of the digitization of data collection. You know, Northridge earthquake, we're filling out forms and they're going into manila envelopes into boxes. Ridiculous in this day and age not to think of data being instantly accessible through, digitized data. Any comments on that based on, your interaction with the adjusters?
Yeah, I want to make a few comments. So I'll do this like these presidential debates while I'll answer a different question first. So I like the one you posed I'll come back to yours, but I like the one you posed for Kelly. And
I have the mute button though.
Yeah, no, I'm sure you do. But I think one thing that is sort of dawning on me is that in addition to all of our sort of micro worlds of, we did some testing, we'd like to do some more testing. We did some claims adjusting, we'd like to expand that. We'd like to acquire more data. We'd like to do this, we'd like to do that. What's sort of dawning on me though, is that there's less than 100 people on this call. There's 40 million people in California. That's the problem. Like, we need to be teaching, talking, promoting, changing the wider world, not us. We certainly have a much better understanding of the problem than we did before this, but what we really want to be doing is change, and your earthquake brace and bolt program is a good example of that. 12,000 is a huge number. On the other hand, there's a lot more homes than that out there. So to me, a focus ought to be, thinking about how to do that effectively. How can we take what we have to create change? It's sort of beyond the engineering world and sort of moving into social science and marketing and all the other things. But I just feel like if we want to make a dent and sort of make the world a better place, then that is maybe a high bang for the buck option. Okay, so come back to your specific question though about the digitization of the world. I think that what we're seeing over the sort of course of my career is greater information technology opportunities and yet chaos. We have an internet that you can't trust. We have, just massive information flows coming at us left and right. Where's the truth? Where is the synthesis? Where is some curated set of information that's of true actual value? And so I think linking forms that Morgan and his team created with the ways they get mapped and Xactimate, with the ways, CAT modelers actually use the information, with the way P58, it's got its locks function created. It was a little bit of my mantra about talking the same language, just on a broader scale. I would like to have, for example, I was seeking this secret anonymous data that the insurance companies have. What if I gave them a format to put it in for me? And what if that format was similar to how people collect information in the field? And what if that were similar to how it can be overlaid with the work that Greg and Dave were doing? The point being, taking this wide world of information and finding a way to standardize it so we can draw meaningful comparisons between the different worlds. And thus we can, in the end, sort of be talking more apples to apples with one another.
I appreciate that. Your choice of words is something that I say often, is that I spent my career as a structural engineer in, engineering and the physical sciences. And now I operate as a kind of a quasi-social scientist because I'm translating. And Cheryl, I definitely want you to weigh in here, but I wanted to go to Evan. Evan, I really appreciate that you sat in on the end of 110, because what we asked very specifically is that we're going to be looking at the 110 retrofit. The other issue that I have in implementing everything is that, and I've said this before with a caveat that I am not trying to insult the construction world, but the residential construction world is a very unsophisticated world. And that is not because these are not extremely talented people, but rather that the margins are so small that they need to have very focused and repeatable retrofit. So any comments on what we've talked about so far, Evan?
You know, a couple of years ago at this forum when we meet in Sacramento, I talked with a guy who, you know, is a home inspector. And we were talking about this idea of, you know, how quickly could you do an assessment of a building, like a P50 assessment, to just see what deficiencies are even there. You know, I mean, I have a 1941 house, but it has a stem wall, and it's got, you know, some small bolts every 5 or 6 feet. So somebody, if I didn't know that, you know, and somebody were to go under the house, and it's a 1-story, you know, wood-sided house, it doesn't need retrofit, right? And you do a P50 type evaluation, and you could understand that. And one of the things he said to me is, you know, it's not that it would take that long, but we're already up at almost 4 hours an inspection. So that's 2 per day. If you go to 5 hours of inspection, that's 1 per day. So you have to double the price of your home inspection because you can only do 1 a day, right? So the frustrating thing about it is that it would be nice to have a very inexpensive way to see if your house meets these different categories. You know, one of the good things that came out of this study is, you know, if you have a wood-sided 2-story house, and, you know, if it's got, you know, if it has a raised triple wall, oftentimes if you can see, you know, a vent under the first floor, and you have a couple of steps you have to go up. You know, I mean, there are some certain ways you could
Simple
do
visual cues.
Yeah. So my point is that knowing the extent of the problem, whether we're using things like what Frank is doing with the AI and using Google Street, you know, to check stuff out, or a really simple $50 way, you know, to assess whether your building even needs retrofit, would go towards what Brett's talking about and being able to educate sort of a mass number of people more quickly, maybe.
Yeah, thank you. Cheryl, I don't see your picture anymore. Nope. So you know that you're right smack where I am in terms of, Evan. You know, we give a hazard reduction discount for our premium of up to 25% for a person who's done this code compliant retrofit, and people have to get either a contractor or engineer to sign the form, so that we have someone who, you know, has some understanding of the retrofit, asserting that yes, it appears to be in conformance. And people, you know, balk at that couple of $100 despite the benefit to the premium reduction. And so we're right smack in that world of trying to find inexpensive ways of getting this. I think I mentioned to you all just a few minutes ago that I don't feel bad going in and retrofitting a 1960s stem wall house, because I don't know that the stucco is well attached. I don't know that they have 1/2-inch bolts at 4 feet on center or 6. I don't know that they're not, you know, decayed. So, and that's a very inexpensive retrofit. And so, you know, we're in that gray area.
So, are you able to hear me now? My visual Zoom popped out for a minute, but
yes.
So this is Cheryl Rabinovich again, and I'm trying to look at these issues from the social science and policy perspective, but actually a lot of that just has to do with economics and also human behavior and psychology. And Brett, I thought you were, you know, really spot on. It's why I shifted around 2005 from working on the physical science modeling of loss into the human behavior about dealing with risk and loss, because that's where I feel like where we need the most leverage and magnify our impact. So I'll start just quickly with what Brett was saying about standardizing data. From my perspective, you also need to standardize data from the homeowner, agent, mortgage broker, loan underwriter, neighbor down the street side, because I know all these concepts have a way to touch those particular groups, and a metric can have a really sophisticated name to a technical audience, but usually there's a way to convey that same concept to lay audiences, in more plain speak. And as much as I see the potential of AI and machine learning, that was a really interesting talk by in the last half hour. There's also the potential to involve homeowners in assessing their own properties. And they are capable, I believe, we've surveyed hundreds to 1,000 of homeowners, and they are capable of reporting things that they see about their home that are meaningful to a home inspector, that are meaningful to an engineer. I believe that spectrum can be attained. Bridge, exactly. What was the last thing that you brought up? I'll stop there for now, and you can ask me more specific questions now that I'm plugged back in.
So with regards to the the simple visual cues and the ability, we have found that people are for the most part, pretty good about being able to assess that their house has the cripple wall vulnerability. Living space over garage, great big garage door, attached garage. That one I think we can move into. But one thing I want to ask you, Greg, because I think, this period shift that you get from the house that's poorly maintained, stucco that's not well anchored, or maybe damaged from a previous earthquake. How big of a difference does that make? Because we've ignored it to a certain extent in peer. I shouldn't say ignored. You modeled what you could, right? But how important is it? Because as I said, I'm ignoring in many cases what's there and just going ahead with a retrofit. So is that period shift a big deal for the one two-story house?
You mean the period shift that would occur from deterioration of the house?
Sorry, yeah. Thank you for finishing my sentence.
Yeah. Okay. Yeah. Let's see. I'm trying to figure out how to. In our analyses, we thought about how we were going to characterize the ground motion, and we chose on one conditioning period, 2.25 seconds. One of the reasons is because that's common in the loss modeling industry to use a 0.3 second period. But there's also been research that shows, especially when you integrate these analyses with the hazard curve, that you don't just look at one intensity. When you integrate it with the hazard curve, the results are not that, the loss results or the probability of collapse are not that sensitive to the conditioning period. So I think in the big scheme of things, I don't think that's a overriding issue. I mean, when the house is deteriorated, if there's a shift in the period, what's probably more important is there's probably a dramatic decrease in the strength. In other words, if you look at the sill plate and if it's rotted, then any connection that you would have between the stucco or the sheathing into that would be ineffective. So I think that's a much more important issue. But I think, like you pointed out, I think rightly so, is that if people retrofit it and it's done appropriately, anything that is deteriorated should be fixed and replaced during that retrofit, so it takes away the uncertainty. And for the cost you're looking at least for the cripple wall retrofit, others are more expensive. I mean, the $5,000 compared to the cost of the damage that could occur, it's kind of a no-brainer. The tricky thing is communicating it, also complacency. I had a friend who just bought a house and has a house over living space over garage, and at the end, just before they signed their papers, they got a discount owner to get that retrofitted, a $20,000 discount off the price of the house. The problem now is that when you move into a house, you have all sorts of expenses.
Granite
so it's like, well, yeah. So there's a little bit of a complacency about getting to those things.
Yeah. Well, you guys are going to think my segues are a little tenuous, but I want to make sure that I get everybody involved. So this one's going to be a little bit of a right turn. But to the ground motion folks, once again, I talked about, how we tell somebody who doesn't live in one of those 4 locations that this one really kind of relates to you. So for example, the northwestern corner of California, which is close to the Cascadia zone, how do I extrapolate to utilize the information that we have now? Not a lot of population up there, horrible in terms of lots of pure and post houses. But the good news is they'll get a new foundation if they retrofit those. So I'm looking right at Sylvia. Can I say that is, like San Francisco? Now I'm pretending I'm not an engineer and I'm asking you a very simple, what I think is a simple question.
Well, it depends, because if you're not up in, what's the town up north? Is it Arcadia?
Yeah. The one that had the, what's the one that had the tsunami?
It's Arcata, the highest ground motion in the state.
Crescent City.
Arcata?
Yeah, so Arcata is right on the fault, so it actually has a really high seismicity. So I think it'd be almost more like San Bernardino than San Francisco kind of thing, the seismicity. Because it's, I believe it's one of the highest ground motions in all of California. And so, and I feel like at this point, once these analyses have been done, that's the next step, is now to go back and map back the different areas to what's going on, to what was done. Yeah. Now, what's tricky about the Pacific North, the very northwest of California, is that brings in the subduction, and we don't have the ground motion models at the same level of testing, and we've just developed ground motion models, so that's definitely the next step. Right. We just wouldn't, right now, we didn't have the capabilities to do the same level of analyses with the subduction as we do with these crustal faults. So that was one reason. But
Janiele, can I make a point? Especially you mentioned that you want to extend potentially to other states. If you want to go to
others will ask me, I'm sure. So I'm preparing myself for that question.
So if you want to go especially to Oregon and Washington, the state of Washington, we have to include subduction. There is no way. Very, very northern California, we may have some combination of crustal and subduction. But if you go to Oregon and Washington, we have to go. And now, as Sylvia said, we have the models and we can move forward. So that's one issue. Is it a good time that I mentioned for a 1 minute issue of uncertainty that you brought up? Okay. Uncertainty in earthquake engineering, we cannot close our eyes in uncertainty. Nothing is really truth, basically. And there are some studies, the multiple studies, that they show the uncertainty of ground motion generally dominates. Unless you get to the collapse issue that basically we don't know really what to do, the uncertainty of structural modeling is high. But especially to 250 years of time period, plus, minus, and so on, uncertainty of ground motion is large. So one thing for futuristic aspects, I think really is good for everyone to do. The way that we do ground motion models and hazards, say in California, we borrow data from Japan, from Taiwan, from Middle East, and so on. And we pray that the ground motion and characteristics are the same. However, in the last, especially 10, 15 years, with so many motions in California, we can do a better job. Not 100%, but we can do a better job to reduce uncertainty that if you are in California. In other words, California-based hazard rather than generic. That we can do.
I think it also brings in the work that Frank is doing with uncertainty quantification, because the uncertainty is really just also associated with variability. So it's not like, oh, we don't know what's going to happen. I mean, there's just so much variability in it. And so if we can quantify, which is one of the early tools that they developed at the Sim Center, then you can do something with it. I mean, we accept this variability or uncertainty as long as we can understand it, and that gives us, so then we can extrapolate the variability in the ground motions into variability in structural and damage response and things like that. I mean, after all, we put so much variability in the ground motions, but we don't put so much in the model, in the structural model itself, right? And
Right.
so that's where the work that Frank comes in, is actually carrying that uncertainty / variability through all the way to the numbers and to the dollars.
So I've got three things I want to cover, and then before we head out. And so one of them is another segue from that. So I think it's pretty safe to say that it's very clear in the subduction zone, the very northern part of the state, that retrofit works. Retrofit is important. I think that's a pretty slam dunk. The other one, as I said, when I am the person who's making decisions on where to spend dollars, I tell people that we are not in the areas of moderate seismicity in California yet, simply because of limited funding. That's not to say that we shouldn't get there eventually. And so I wondered does anybody disagree with that statement, that someday, we should be retrofitting these vulnerable houses in Bakersfield and in Sacramento?
Absolutely.
Anybody? Awesome. So let me get to testing.
Can I just add one quick thing to that, Janiele, which is just a call to consider for our profession, what does equity mean? And there are implications for our profession of the wider societal dialogue that's going on right now about where we ought to spend our social efforts. And, what is seismic mitigation equity is an interesting question, not for this forum, but something to throw out there. Communities and the state and the political process should have a role in deciding our priorities under seismic mitigation equity.
I think, Cheryl, I appreciate that. And as I said, we are very seriously developing a low-income program. And as I said, you can imagine with the disparity in the cost of a retrofit in the San Francisco Bay Area. And then somebody used, I think it may have been you, Cheryl, it was Brett, very, very wisely was talking about trust. And I'm acutely aware when we opened up Earthquake, Brace, and Bolt that people said, who are these people that are giving money away? What are they trying to sell? We had to go in and develop trust, and that is utilizing relationships with people who are already trusted in the community. So I'm very, very aware of that. I wanted to touch on so that we don't run out of time, about testing, is to dream about a living space over garage testing program. We enter into a very different, well, it's not too different, but there's a lot of proprietary products in that market, and growing number of them. And so I've kind of waffled with, the CEA having to pay to test somebody's proprietary product, or can you use some form of performance prescriptive methodology? Tara, Kelly, anybody have any thoughts on that? Did we lose Tara?
No, I'm here.
Oh,
I'm listening in. Can you hear me okay?
Yeah. There's a lot of testing that's gone into many of these, right? Can you utilize that?
Yeah, of course. I'll go back to something Brett said a while ago. A large part of the success of anything you're doing here is tied to the communication and visibility of the work, of the really good work here. And here we are, less than 100 folks discussing the importance of the issue. We're largely self-promoting. So, I come from a vantage, and of course I'm a large proponent of full or large scale testing, but I was driven by that because society responds to catastrophic events, fortunately, when it affects them or their neighbor. I mean, if I sit back in Southern California here and take a look at the California fires across the state, as Northern California might have wrestled with fires while Southern California was relatively, let's say, safe a month or so ago, the situation is constantly shifting as weather patterns shift. So these contrasting scenarios are, amongst us every day, and equally other threats like earthquakes that we're dealing with here. So I really feel strongly that teaching and promoting, can be a large part of your propensity for success. It's this idea of disseminating the importance of the issue by replicating a scenario I think it could carry the insurance industry's message more directly to the homeowner. So but of course I come to it from the science perspective and the desire to see those executed, to learn those experiments executed. But I also recognize that not only providing the science-based evidence, the video-based, the image-based, and ultimately the media coverage that we can garner, you know, from a real earthquake test of a real home is going to carry this message very far, because we have an opportunity to do that. So, you know, I worked with Lee and others in the CEA peer team to try to give some ideas, shed some light on what that might look like for future testing, and I'm still a big supporter of that. As far as addressing the differences between proprietary product tests that have been conducted and sort of generic tests, I think we should focus our efforts on performance objectives and let the science and the design code inform us regarding those performance objectives and guide the design of an experiment by those, because that's what the engineering community would be doing. And so that's what the homeowner would ultimately have under their belt, and they would have under their belt in whatever performance objective stage their dwelling was at, you know, putting it in Evan's words, you know, 1945, 45 to 55, and then more modern construction up to the 1970s and the like. So I don't think we should be, and I worked on testing of proprietary components, connectors, subsystems. You know, I think those are extremely valuable, but I think the genericism needs to be there so that it can translate into useful data for validating models, and to useful best practices for the engineering community, and ultimately, you know, better mitigation strategies that'll be more robust for the engineering community to implement.
That's very helpful. Thank you. Peng, I wanted to give you an opportunity. If did you have anything?
I don't know if Kelly wants to comment.
Oh, Kelly, go ahead, Kelly.
While we're on the subject of testing, I'm so sorry.
No worries, got it.
My partner in crime, Kelly.
Okay, I wanted to mention that in the ATC 110 project, we have come up with simplified engineering and prescriptive pre-engineered solutions for the living space over garage homes. And that has, through Vicky's work, included incorporation of proprietary elements, and that there were really performance criteria set up for the elements that were brought into the modeling. Maybe Peng can talk a little bit more about that. But and similarly, I think we had some proprietary elements in the cripple wall tests that we were doing, and we can do limited testing. We really need to take the next step that we've already taken with cripple walls, with the living space over garage homes, and maybe with the hillside homes down the road. But it does mean some amount of testing and modeling, loss modeling, numerical modeling to quantify the benefits of it. And it probably takes some of Frank's work looking at scenarios and being able to explain to the public the benefit of it. But I think it can be done dealing with the proprietary nature in an appropriate fashion.
Thank you. Peng, did you have anything to add? You are on mute. There you go.
Yeah, I want to echo what Kelly mentioned. I agree for the proprietary system. Actually, I work on the room over garage analysis. We can define the performance criteria. For example, the ductility needed and the overstrength and so on. And then what kind of backbone we try to achieve. We test out the concept in ATC 110 project, actually obtain one real test from one of the manufacturer of moment frame. So we test out the concept, actually it works. You just need to define what kind of target, and then just let the industry come up with their solution. We don't care how they make that, how they, what kind of voodoo they put into their frame, as long as they can meet the strength, ductility, and so on, and the hysteretic behavior. And we should get the same performance. Yeah.
Thank you. So we have 4 minutes left. David or Frank, Farzine, anything to add? No, I'm not. David, I can't see your head if you're nodding, but if you wanted to, I see your microphone go on. No. Anybody else? There he is. Anything to add, David?
Sorry, my connection's still not that good, so I've been remaining invisible.
In the backwoods of New York there?
Yeah, the weather calmed down a bit, but well, I guess my only comment was relating to the uncertainty, and I guess just one of my big takeaways dealing with two projects now, working with these old existing wood frame houses. Just as much as I would love to understand the influence of deterioration and let's say some kind of decay and something that would be a little bit more detrimental. I'm also very interested in understanding what more of the other range of things are. This is going along with a lot of discussion I had with Charlie Kircher, just bringing up the point that a lot of times some of this old construction, it's going more in the they don't build them like they used to regime. And until we can really understand a little bit more about the range, because we're using the best information we have, it will. That's just one of the other aspects that's really hard for uncertainty quantification, because unless we understand where central tendency is, you can put dispersion and correlation factors on a bunch of different parameters, but if you don't have the right central tendency, it's very difficult to understand where you're actually at. I guess that's my only statement.
Great, thank you.
Can I add something real quick?
Yeah,
so,
oh, there he is.
This group can do all the engineering, right? I'm talking as a homeowner myself. I went out to my roof, look at the roof truss. I saw this toenail. It's the bad roof construction. I know I need to do something, but life goes on. I bought the house anyway.
Yeah.
There's other more important things. So I feel like, hey, I still can take my chance. The tornado or the big wind's not going to happen the next year or the next month. So I don't know. I can't even convince myself as an engineer to act. So I'm not sure how we do that.
Yeah, well, we are risk takers, Peng. Human beings are. Grace, anything as our project coordinator you'd like to add?
I have a great respect for the engineering and the science and the research, but I think Brett had a really good point, and that is how certain, well, we're never going to say we're certain, right? Because we're talking about uncertainties and variabilities. But what is the prevailing message that we would give to our neighbors, given what we've learned from this project? What is the message that we would provide to, the other homeowners who are definitely outside of this realm, who are outside of the EBB realm? What would be the benefit to Fresno? We're talking about social equity, to Fresno, to West Sacramento, to other areas that would be impacted, that could be positively impacted by the results of our work. So it's interesting. One of the things that I've always tried to turn in my head is, what would I tell my neighbors? I live on a fairly modest street with a lot of older homeowners who've been there forever. They've been there longer than I've been there. What would motivate them to improve the quality of their cripple wall home? And at this point, it's because they're fully vested now in their property. So that's one thing. There's the economic component of it, but I think the other component definitely is the communication. This is what could happen in a moderate to major earthquake, and it's not collapse, it's damage. And how would your life be impacted? So it's interesting. We had the opportunity to work with the California Seismic Safety Commission to produce a 4-page brochure, very similar to what this project has produced in 6 pages. But it was the underlying premise in our piece was, what is the expected earthquake performance of buildings designed to the current California building code? Not the older, not your older homes, but the current standard. And there, the message also is, it's for life safety. It doesn't mean you may be able to go back into your building and it may not be functional, but we wanted to bring that message through as a very fundamental message. So I'm thinking back to fundamentals. What would be the message from this group, from the product of this work, that we could convey to our neighbors without saying, well, there's this much certainty or that much certainty. We'd say, we studied all of California, right, Sylvia? All of California, and this is what we found. This is the benefit, you know, and it's, you have stucco, you have wood siding. It doesn't matter what your house looks like. If you have a crippled wall, if it's not reinforced, you're going to benefit from this.
Well, I thank you all, and I wish that I was concerned I wasn't going to be able to fill this time slot. When we can all meet together again in person, the coffee, tea, or adult beverages on me. It has been a pleasure to work with you and a pleasure to listen to you. We have one more speaker with an incredible presentation, but before we go, Evan, I wanted to tell you that I've already done your post-event study. And anecdotally, in the Napa earthquake, I saw almost every red tagged house, and they were all horizontal siding and short cripple walls, the exception of that one green house. Can't quite figure that one out. So done. We're done here. But I do commit to you that I think it's essential. We now, as I said, have over 12,000 houses retrofitted in areas of high hazard. Those are potential research projects in the future.